Interference detection is a powerful assembly evaluation tool within SOLIDWORKS. There are already a number of excellent tutorials available online which go to some depth in explaining how this tool can be used to evaluate complex assemblies. But let's spend just a few moments to cover the basic functionality using this basic assembly. There are 4 components in the assembly, one of which is a subassembly consisting of 2 plates held together with 4 screws from the toolbox, and 3 pegs that fit into the holes in the top plate. Now that we've seen how the assembly is put together in SOLIDWORKS, we'll use interference detection to verify that it can be assembled in real life. When I launch the tool with nothing pre-selected, note that the entire assembly is selected by default. Following the prompt, I'll go ahead and calculate to see the results. The system checks for interference or overlaps between all components in the assembly, even those within sub-assemblies, unless I've excluded any components from the calculation. Each interference is listed along with the volume shared by the 2 components, which are listed down below. If you prefer, you can reverse this layout, but I'll stick with the default view. For complex assemblies, you may find it helpful to change the display style for components that aren't involved to make it easier to see interfering parts. Those interfering parts can be made transparent too, to make it easier to see where the overlap is. I'll leave those options alone. Now, these pegs shouldn't be press fit here, so there needs to be some clearance between the side faces of each peg and the walls of its respective hole. There's a clearance detection tool for that, but that's a subject for another video. For now, I just want to make sure that the pegs don't contact their holes, so I will treat coincidence as interference. Now I can see all points of contact in the list, not just the overlaps. But that list returns a lot of results that don't really concern me, so I'd like to clean up the list a bit. Now, first of all, I know that there is going to be interference between the bolts and threaded holes. Since the hole is modeled to its minor diameter and the screw to its major, there will be overlap where the threads engage. So I can safely ignore those results. This option will put all the interferences that relate to fasteners in their own folder and out of the way. Of the remaining interferences, I can see coincidences where the pegs touch the bottom plate and where the top plate touches the bottom plate, so I'll ignore those. So I can see that the square peg has an interference fit, so I'll want to change the dimension slightly to undersize it. And I can also see that the round peg is not merely touching, but it's overlapping the bottom plate. Looks like it's just inserted too far, probably missing a mate, so I'll need to dismiss the interference detection tool to make those changes. The round peg just needs a coincident mate added, which in 2014 is especially easy to do. I'll just hide this plate, control select both faces, and the mates pop up right next to my cursor. And if I adjust the dimension of the square peg, and rebuild, that should take care of that. Back in the interference detection tool again, I can see now that the only item in the list is where the round peg touches that bottom plate. Remember, there are lots of other items that I've ignored. I can show those again with this option and unignore them if I want to. Aside from ignoring interferences, excluding certain components, and shoving all the fasteners into their own folder, I can also exclude from this list any interferences between components within a subassembly. So with this option checked, I don't see those interferences between the screws and the plates anymore because they're part of the same subassembly. And since none of these interferences really concern me, let's take a look at just that subassembly. Now, because this assembly has no subassemblies in it, this check mark down here makes no difference. Incidentally, if you use multi-body parts in an assembly, this option will check for interferences between solids in a single part file, but note that interference detection can never be performed on surface bodies. Now, just as before, I'm going to clean up this list by putting fasteners into their own folder, and this one remaining coincidence between the plates can be ignored and hidden from view. Now, as you might have guessed, it can be dangerous to just ignore all these interferences simply because they're fasteners. After all, a screw that's too long can cause problems, screw heads can cause clearance issues, etc. So that's where this option comes in. This will further differentiate fasteners, adding another folder for threaded fasteners which are in the correct sized hole. In other words, the only interferences that will show up in this folder are those expected thread engagement overlaps between parts that can actually thread together. In my case, the folder is empty, which tells me that these fasteners are the wrong size for the holes. So if I look at the top plate, I see that it has counterbores for M20 socket head cap screws. But the bottom plate is threaded for M18s. And sure enough, the fasteners themselves are M20s. So I'll need to dismiss the interference detection tool and fix that bottom plate. I'm going to open up that subassembly and edit that hole wizard feature. Adjust the size to 20 by 2.5. Now, since the system checks for matching cosmetic threads, I'm going to want to make sure that they are being created here in the wizard. I'll select everything that's hidden and unhide those components. Do a quick rebuild and then check for interference one last time. Now, I've already fixed all the coincident interferences that needed fixing, so I've gone ahead and cleared that option to view them. And now that I can see all those thread engagement interferences listed in the Matching Cosmetics thread folder, it confirms that all my threads are the correct size. Now, I want to reiterate that the system is checking cosmetic threads here to make sure that they're both the same. So this is a good reason to use hole wizard features and toolbox fasteners, since those can have cosmetic threads added automatically, as long as you've enabled those options. If not, or if you've created your own threaded part without cosmetic threads, they won't be added to that matching threads folder. And you can avoid this sort of thing altogether if you add your holes at the assembly level using hole series or hole wizard features. Well, I hope that you found this helpful, and thanks for joining me.